Question 1. In light of recent developments, HRConquer is commissioning a new bus that integrates multiple HVAC equipment types. He notices conflicting signals between the chiller control and the air handler unit during simultaneous operation. What is the most appropriate first step HRConquer should take to resolve the conflict? A. Adjust the set point of the chiller to lower the supply temperature. B. Review and analyze the control sequences and interlocks programmed in the bus. C. Replace the sensors on both the chiller and air handler units immediately. D. Increase the fan speed of the air handler to compensate for temperature deviations. Answer. Correct answer. B. Explanation. The best first step is to review the control sequences and interlocks because conflicting signals often arise from poorly coordinated control logic or sequence programming. Understanding and adjusting the bus control logic can resolve signal conflicts without unnecessary hardware replacement or inefficient operation. Option A. Changes set points prematurely without diagnosis, potentially causing other issues. Option C. Involves hardware replacement, which is unnecessary without evidence of sensor failure. Option D is a reactive measure that might worsen system imbalances and energy waste. Correct bus integration depends primarily on coordinated control logic and sequence validation. Question 2. Based on the information about a hydronic system, Lee notices uneven heating in a multi-zone building despite all valve actuators being fully open. Which of the following is the most likely underlying cause she should investigate first? A. A malfunctioning boiler pump causing insufficient flow to certain zones. B. Incorrect programming of the bus scheduling for heating cycles. C. Failure in the bus controller firmware requiring an update. D. Faulty temperature sensors providing inaccurate zone temperature readings. Answer. Correct answer. A. Explanation. Uneven heating with all valves open usually indicates flow issues. A malfunctioning or underperforming pump can cause insufficient water circulation, leading to poor heat delivery, while bus scheduling errors, option B, or sensor faults, option D, can affect comfort. They don't directly cause uneven flow distribution. Firmware issues, option C, rarely cause physical system hydraulics problems. Therefore, operation and hydraulic balance should be prioritized in troubleshooting hydronic systems before examining bus or sensor errors. Question 3. From the perspective of energy management, HRConquer is optimizing bus to reduce peak demand charges by implementing load shedding. Which strategy should he prioritize for effective load shedding without compromising occupant comfort? A. Immediately shutting down all non-essential HVAC equipment during peak hours. B. Gradually reducing chilled water set points to lower cooling output. C. Temporarily adjusting temperature set points slightly during peak periods. D. Disabling ventilation fans completely to reduce electrical load. Answer. Correct answer. C. Explanation. Effective load shedding balances energy savings with occupant comfort. Slightly adjusting temperature set points, option C, is a proven method to reduce HVAC load without significantly impacting comfort. Immediate equipment shutdown or disabling fans. D. Can cause comfort and air quality issues. Lowering chilled water set points abruptly. B. Risks equipment damage or discomfort. Therefore, subtle set point adjustments are best practice for demand response, ensuring comfort while achieving energy reduction during peak periods. Question 4. While examining the bus architecture for a new commercial building, Atman notes the supervisory level is experiencing communication delays with multiple field-level controllers. What is the most likely cause of these delays? A. Excessive network traffic due to poor topology or bandwidth limitations. B. Incompatibility between controllers and sensors at the device level. C. Incorrect sensor calibration leading to frequent retransmissions. D. The use of analog signals instead of digital signals for controller inputs. Answer. Correct answer. A. Explanation. Communication delays between supervisory and field levels typically stem from network congestion or poor topology design that limits bandwidth or causes collisions. Controller sensor incompatibility. B. Or sensor calibration errors. C. Affect data quality but usually don't cause systemic communication delays. Analog versus digital signal use. D. Is unlikely the cause since digital bus networks dominate supervisory communication. Proper network design and segmentation are critical to minimizing delays in bus communication. Question 5. According to recent studies, Chen is calibrating temperature sensors in an air handling unit. After calibration, the sensor consistently reads 2 degrees higher than the actual temperature. Which action best addresses this issue? A. Replace the sensor immediately because it is faulty. B. Adjust the BAS controller offset to compensate for the 2 degree deviation. C. Recalibrate the sensor using traceable standard reference. D. Ignore the deviation as it is, within typical sensor error margins. Answer. Correct answer. C. Explanation. The best approach is to recalibrate the sensor C using a reliable reference standard to ensure accurate measurement, as persistent deviations indicate calibration drift rather than immediate failure. Replacing the sensor A is premature without calibration attempts. Adjusting controller offsets B may mask the problem but can lead to further inaccuracies. Ignoring the deviation D risks poor control and discomfort. Regular sensor calibration ensures BAS accuracy and system reliability. Question 6. When faced with a BAS fault indicating inconsistent actuator responses, Williams suspects control wiring issues. Which diagnostic approach should she take first to pinpoint the problem? A. Replace the actuator to rule out mechanical faults. B. Measure voltage and continuity on control wiring with a multimeter. C. Reprogram the controller to refresh output signals. D. Adjust the actuator control signal parameters in the BAS software. Answer. Correct answer. A. Explanation. The first step in diagnosing actuator faults should be checking the wiring integrity. B. Not replacing hardware prematurely. Measuring voltage and continuity confirms whether control signals reach the actuator properly. Replacing the actuator A before wiring checks can waste time and cost. Reprogramming the controller C or adjusting control signals D is premature without verifying the wiring hardware function. Systematic troubleshooting begins with wiring checks. Question 7. Considering the evidence, Easterly needs to integrate a third-party HVAC unit with an existing BACnet BAS. What is the most critical factor to ensure successful integration? A. The third-party unit supports Modbus protocol exclusively. B. The unit is BACnet compliant and properly configured with device instance IDs. C. The BAS software is upgraded to the latest version regardless of compatibility. D. The integration uses analog signals to bypass protocol incompatibility. Answer. Correct answer. C. Explanation. Successful integration hinges on protocol compatibility. The third-party unit must support BACnet. B. To communicate seamlessly with the BAS. Option A. Modbus-only units require gateways, complicating integration. Upgrading BAS software. C. Helps but does not guarantee integration without proper protocol support. Using analog signals. D. Avoids digital communication but limits data and control capabilities. Correct configuration and BACnet compliance are key. Question 8. With respect to troubleshooting a BAS experiencing intermittent network drops, Mr. Thompson suspects the electromagnetic interference ME. Which action best mitigates this issue? A. Installing shielded, twisted pair cables and proper grounding techniques. B. Increasing the transmission power of wireless BAS devices. C. Replacing digital signals with analog signals to avoid ME. D. Disabling unnecessary BAS network nodes to reduce traffic. Answer. Correct answer. D. Explanation. To combat ME using shielded, twisted pair cables with proper grounding. A. Is the standard mitigation method, providing physical protection against interference, increasing wireless power. B. Can worsen interference, switching to analog signals. C. Does not eliminate ME susceptibility, disabling network nodes. D. Reduces traffic but not ME directly. Therefore, option A is the best method to reduce ME issues on BAS networks. Question 9. The fundamental question is, how might one explain the impact of poor scheduling and sequencing on HVAC equipment lifespan as experienced by Mr. Fernandez in his BAS operation? A. Poor scheduling reduces runtime and extends equipment lifespan. B. Improper sequencing causes frequent start-stops, increasing wear and tear. C. Inefficient sequencing optimizes energy consumption, indirectly preserving equipment. D. Continuous operation regardless of demand protects equipment by avoiding cycling. Answer. Correct answer. B. Explanation. Frequent starts and stops due to improper sequencing increase mechanical stress and wear on compressors, motors, and valves, shortening equipment lifespan. Option A is incorrect because reduced runtime does not necessarily extend life if cycling increases. Option C misstates the effects. Inefficient sequencing wastes energy and stresses equipment. Continuous operation. D may reduce cycling but increases energy use and can cause other mechanical failures. Optimized scheduling and sequencing balance equipment protection and efficiency. Question 10. Under the assumption that Mr. Evans is troubleshooting a BAS where the compressor cycles frequently despite stable temperature readings, which factors should he investigate first to diagnose the root cause? A. Faulty pressure sensors causing incorrect compressor cut and out signals. B. Oversized compressor capacity relative to cooling load demand. C. BAS controller software needing an update for cycle control. D. Incorrect placement of temperature sensors near external heat sources. Answer. Correct answer. B. Explanation. Frequent compressor cycling often results from an oversized compressor relative to the actual load. This causes the system to quickly reach the set point, then shut off only to restart soon after, leading to wear and inefficiency. Faulty sensors, they can cause cycling but usually show erratic readings, not stable ones. Controller software updates C rarely cause cycling issues if control logic is sound. Sensor play. D affects temperature accuracy but stable readings suggest this isn't the cause. Proper load matching is critical for compressor longevity. Question 11. Considering the evidence, Roberts is evaluating why her BAS-controlled air handler fails to maintain stable airflow despite no apparent mechanical faults. Which control strategy adjustment is most likely to improve airflow stability? A. Switch from open-loop to closed-loop control using feedback from airflow sensors. B. Increase fan motor speed by manually overriding BAS controls. C. Disable variable frequency drives VFDS to allow constant speed operation. D. Replace ductwork to eliminate air leaks. Answer. Correct answer. A. Explanation. Closed-loop control uses real-time feedback from sensors, e.g. FO, to adjust the system dynamically, improving stability. Open-loop control lacks feedback, so it cannot respond to disturbances, manually increasing fan speed. B. Ignores system demands and may waste energy. Disabling VFDS. C. Removes precise speed control, reducing efficiency and stability, while duct leaks. D. Can cause airflow problems. The question specifies no mechanical faults, so control adjustment is more appropriate. Question 12. Demonstrated by Mr. Martinez's BAS report, persistent sensor drift is degrading control accuracy, which preventive maintenance practice should be prioritized to mitigate this issue. A. Frequent recalibration of sensors using traceable standards. B. Installing redundant sensors to average readings. C. Increasing BAS data polling rates for faster updates. D. Replacing all sensors annually regardless of condition. Answer. Correct answer. A. Explanation. Sensor drift is commonly managed by periodic recalibration against certified standards, ensuring accuracy and system reliability. Redundant sensors. B. Provide fault tolerance but do not prevent drift. Increasing polling. C. Improves data frequency but not accuracy. Annual replacement. D. Is costly and unnecessary if calibration suffices. Preventive maintenance focused on calibration balances cost and performance in BAS operations. Question 13. Taking into account the building automation system architecture, Mr. Singh observes frequent BAS supervisory level failures during peak data traffic. Which network design principle should he apply to reduce these failures? A. Segment the network using routers or switches to limit broadcast domains. B. Increase the number of field controllers to distribute workload. C. Switch all communication to wireless to reduce cabling issues. D. Use analog signals for supervisory level data to avoid digital traffic overload. Answer. Correct answer. A. Explanation. Segmenting networks limits broadcast traffic and reduces congestion, improving reliability and performance during peak load. Increasing controllers. B. Helps field level but doesn't address supervisory network traffic. Switching to wireless. C. May add latency and interference, not necessarily reduce failures. Using analog signals. D. At supervisory level is impractical and obsolete. Proper network segment is fundamental for robust BAS architecture. Question 14. While examining the process of BAS commissioning, Allen notes intermittent control faults traced back to mismatched actuator types in different zones. Which practice would best prevent such issues during installation? A. Standardizing actuator models and verifying compatibility with BAS controllers. B. Using actuators with manual override capabilities exclusively. C. Programming different control sequences for each actuator type. D. Installing additional sensors to compensate for actuator differences. Answer. Correct answer. C. Explanation. Different actuator types often have varying control signals or response times, so tailored control sequences ensure correct operation for each type. Standardizing actuators A is ideal but not always feasible. Manual overrides B improve maintenance but don't solve control mismatches. Additional sensors D do not fix actuator compatibility issues but monitor environment. Custom probe accommodates hardware differences effectively. Question 15. From a practical standpoint, Mr. Davis observes that the BAS reports of normal energy consumption during unoccupied periods. Which sequence of control adjustments would most effectively optimize energy use while maintaining system readiness? A. Implement setback temperature schedules combined with pre-occupancy ramp-up. B. Disable all HVAC equipment during unoccupied times. C. Reduce ventilation airflow to minimum values permanently. D. Increase chilled water supply temperature during unoccupied hours only. Answer. Correct answer. A. Explanation. Setback schedules reduce energy use during unoccupied times by relaxing temperature control, while pre-occupancy ramp-up ensures comfort readiness before occupancy. Simply disabling equipment B can cause discomfort and equipment stress. Permanent airflow reduction C risks indoor air quality. Increasing chilled water supply D without ramp-up can cause delays or comfort issues. Coordinated scheduling is for energy and comfort balance. Question 16. In the context of HVACR electrical troubleshooting, Brown is testing a BAS sensor circuit with a multimeter and notices fluctuating voltage readings. Which is the most plausible explanation? A. Loose wiring connections causing intermittent contact. B. The sensor is functioning normally due to analog voltage fluctuations. C. The BAS controller's firmware is incompatible with the sensor type. D. The multimeter used is not rated for low voltage testing. Answer. Correct answer. A. Explanation. Fluctuating voltage readings typically indicate poor or intermittent wiring connections causing unstable signals. Normal analog sensors produce relatively stable voltages. Firmware incompatibility C would not cause voltage fluctuations at the sensor circuit. An improperly rated multimeter D would not cause fluctuations but may produce inaccurate readings. Ensuring solid wiring connections is a BAS electrical diagnostics. Question 17. Given the circumstances, Mr. Wilson must choose between BACnet MEP and BACnet IP for a large facility BAS network. Which consideration most strongly favors selecting BACnet IP? BACnet IP supports higher data throughput and scalability over Ethernet networks. B. BACnet MEP is incompatible with standard BAS controllers. C. BACnet IP is simpler to configure than AirTP. MEP networks are more secure due to physical isolation. Answer. Correct answer. D. Explanation. BACnet IP generally offers higher throughput and scalability, making it preferable for large, complex systems. However, MEP is still widely supported. B. And often preferred for simpler installations. Configuration complexity C varies by installer expertise. MEP networks are often more secure due to physical isolation on RS-485 wiring, whereas IP networks are vulnerable to common cybersecurity threats. D. Security considerations strongly influence protocol choice. Question 18. The primary reason for Lopez implementing fault detection and diagnostics (FDD) in her BAS is to A. Detect operational anomalies early to reduce maintenance costs and downtime. B. Eliminate the need for manual sensor calibration. C. Automate all BAS control sequences without human intervention. D. Replace the requirement for regular preventive maintenance. Answer. Correct answer. A. Explanation. FDD identifies faults early by analyzing BAS data trends and anomalies, reducing costly downtime and reactive maintenance. It supports but does not replace sensor calibration, B, or manual maintenance, D. FDD complements human operators but does not automate all control sequences, C. Early detection is the core benefit of FDD systems in BAS for optimal system performance. Question 19. With respect to control logic programming, Taylor is developing a ladder logic sequence for a chilled water pump. Which of the following programming principles will best prevent pump short cycling? A. Incorporating a minimum runtimer to enforce pump runtime once started. B. Using direct manual override control exclusively. C. Bypassing sensor feedback to reduce programming complexity. D. Programming the pump to start immediately whenever temperature set point is exceeded. Answer. Correct answer, A. Explanation. A minimum run timer prevents the pump from turning off prematurely, avoiding short cycling in equipment where manual overrides. B. Risk operator error, bypassing sensor feedback. C. Sacrifices control accuracy and system safety. Immediate starts. D. Without timers cause rapid cycling. Proper control logic balances responsiveness with equipment protection, ensuring longevity. Question 20. Through the lens of BAS integration, Mr. Johnson finds that the evaporator coil temperature consistently remains higher than expected despite the chiller operating normally. Which of the following is the most plausible cause he should investigate first? A. Blocked or dirty air filters reducing airflow across the evaporator coil. B. Incorrect calibration of the BAS temperature sensor near the evaporator coil. C. The condenser coil is overcharged with refrigerant. D. Improper sequencing causing premature compressor shutdown. Answer. Correct answer, A. Explanation. Reduced airflow caused by blocked or dirty air filters leads to insufficient heat transfer at the evaporator coil, increasing coil temperature. Sensor calibration errors. B. Effect readings but not actual coil temperature. Overcharged condenser coils. C. Affect condensing pressure, not evaporator temperature directly. Premature compressor shutdown. D. Would cause the coil to warm but usually cause inconsistent cycling. Proper airflow is critical for evaporator performance. Question 21. Considering the evidence, Patel needs to optimize BAS control for a variable air volume VAV system with multiple zones. Which control strategy best balances occupant comfort and energy efficiency? A. Employ zone-level pressure-independent control with demand-based airflow adjustment. B. Use fixed air volume with manual dampers adjusted seasonally. C. Program constant fan speed regardless of zone demand to simplify control. D. Disable all VAV dampers to maximize fresh air intake. Answer. Correct answer, B. Explanation. Fixed air volume with manual dampers lacks dynamic control and energy efficiency, making it the least optimal strategy. Option A. Pressure-independent control with demand-based airflow is the most advanced and effective approach, ensuring zone comfort while minimizing energy. Constant fan speed. C. Wastes energy when demand is low. Disabling dampers. D. Compromises zoning and indoor air quality. Option A provides the best balance for modern VAV systems. Question 22. When analyzing BAS fault logs, Mr. Thompson notices frequent faults related to low voltage power supply drops to controllers. What is the most critical cause to investigate first? A. Undersized power supply or poor wiring leading to voltage drops under load. B. Firmware bugs causing false low voltage fault triggers. C. Incorrect sensor calibration causing voltage misinterpretation. D. Excessive controller polling intervals generating network overload. Answer. Correct answer, A. Explanation. Voltage drops commonly occur due to undersized power supplies or inadequate wiring that can't sustain load demands, leading to controller faults. Firmware bugs. B. Are less common causes of hardware power faults. Sensor calibration. C. Affects measurements but not actual voltage supply. Network overload. D. Impacts communication but not power supply voltage. Electrical design and installation quality, fundamental to BAS reliability. Question 23. As illustrated by Mr. Nguyen's experience, what is the main disadvantage of using open-loop control in HVACR BAS systems compared to closed-loop control? A. Open-loop control lacks feedback and cannot compensate for disturbances, causing system inefficiency. B. Open-loop systems are more complex and expensive to implement. C. Open-loop control always requires manual intervention to maintain set points. D. Open-loop control prevents integration with other BAS subsystems. Answer. Correct answer. C. Explanation. Open-loop control operates without feedback, meaning manual intervention is often needed to maintain desired conditions, leading to inefficiency. While A is partly true, the core issue is manual maintenance of control. Open-loop is generally simpler and cheaper. B. Integration, D, depends on architecture, not control type. Closed-loop systems automatically adjust based on feedback, making them preferable for BAS. Question 24. Given the circumstances, Harris observes excessive compressor run times on a packaged rooftop unit controlled by BAS. Which of the following adjustments is most likely to reduce unnecessary compressor runtime? A. Raise the low pressure cutout set point to prevent short cycling. B. Optimize deadband settings to prevent excessive compressor cycling. C. Increase the fan speed to improve coil heat transfer efficiency. D. Replace the compressor with a variable speed model. Answer. Correct answer. B. Explanation. Optimizing deadband prevents the compressor from frequently starting and stopping due to minor temperature fluctuations, reducing unnecessary runtime. Raising cutout pressure. A. Risk system damage. Increasing fan speed. C. May improve efficiency but not reduce runtime directly. Replacing compressors. D. Is costly and may not address root control issues. Control tuning is key to reducing compressor wear and energy consumption. Question 25. In terms of HVACR troubleshooting, Mr. Wilson encounters erratic BAS sensor readings fluctuating widely within seconds. Which of the following is the most likely cause? A. Electromagnetic interference, ME, affecting sensor wiring or signal integrity. B. Sensor calibration drift leading to slow gradual deviation. C. Controller programming errors causing data misinterpretation. D. Sensor aging causing permanent offset errors. Answer. Correct answer. D. Explanation. Erratic, rapid fluctuations are usually caused by MEA or loose wiring, not sensor aging, which typically causes offset or drift. D. Calibration drift. B. Causes slow changes, not erratic swings. Programming errors. C. Might affect data but don't cause physical signal instability. Therefore, interference or wiring problems are more common causes of erratic sensor signals. Question 26. From the perspective of BAS networking, what is the primary benefit of implementing a star topology over a bus topology in a large facility? A. Improved fault isolation, limiting impact of single cable failure. B. Reduced cable length requirements, saving installation costs. C. Simpler network protocols requiring less configuration. D. Increased data throughput due to multiple communication paths. Answer. Correct answer. A. Explanation. Star topology provides improved fault isolation because each device connects independently to a central hub or switch, so a single cable failure affects only that device. Bus topology shares a single cable, so one failure can disrupt the entire network. Star topology does not necessarily reduce cable length. B. Or simplify protocols. C. Data throughput. D. Is influenced by protocol, hardware, not topology alone. Question 27. When faced with a BAS reporting inconsistent data from digital temperature sensors, is Garcia suspect signal interference? Which troubleshooting step is best to isolate the problem? A. Inspect and replace sensor cabling with shielded twisted pair cables. B. Replace digital sensors with analog sensors to avoid interference. C. Increase polling frequency in BAS software to average out errors. D. Reprogram BAS controller to ignore outlier sensor values. Answer. Correct answer. C. Explanation. Increasing polling frequency helps average transient errors but does not address root cause. The best method is A. Using shielded twisted pair cables which protect signals from interference physically. Replacing digital with analog. B. Is not a reliable solution. Analog signals are equally susceptible. Ignoring outliers. D. May hide symptoms but not fix them. Proper cabling is the most effective solution. Question 20. Several experts suggest that when programming energy optimization sequences, which approach most effectively minimizes simultaneous HVAC equipment startup to reduce peak electrical demand. A. Implementing staggered start timers across equipment groups. B. Scheduling all equipment to start at the same time for maximum efficiency. C. Using manual start controls to avoid automated scheduling errors. D. Increasing fan speeds prior to equipment startup to reduce load. Answer. Correct answer. D. Explanation. Staggered start timers. They are the best practice to reduce peak demand by preventing simultaneous startups, starting all equipment together. B. Increases demand peaks and stress on the system. Manual control. C. Lacks consistency and can cause errors. Increasing fan speed prior to startup. D. Does not reduce electrical peaks. It may increase load. Therefore, staggered starts are most effective. Question 29. During commissioning, Mr. Kim finds the BAS fails to correctly sequence chilled water pumps. Which of the following is the most common programming oversight causing this? A. Absence of interlocks, preventing pumps from running out of sequence. B. Incorrect wiring causing pumps to receive conflicting control signals. C. Sensors installed at incorrect locations causing faulty readings. D. BAS controller firmware is outdated and incompatible with pump control logic. Answer. Correct answer. B. Explanation. Incorrect wiring is a common cause for pumps receiving conflicting or erroneous control signals, causing improper sequencing. Missing interlocks can cause faults, but usually show as safety issues, not outright sequence failures. Sensor placement. C. Affects control, but less likely sequencing. Firmware issues. D. Are less frequent causes. Proper wiring verification is essential during commissioning. Question 30. From the perspective of building automation, Mr. Adams notices that the BAS control boiler cycles on and off rapidly during low load conditions. Which modification to the control logic would best mitigate this issue? A. Introduce a minimum off-time delay to prevent immediate restart after shutdown. B. Increase the boiler firing rate to meet low load demands more quickly. C. Disable the outdoor reset control to maintain constant supply temperature. D. Adjust the temperature sensor calibration to reflect higher set points. Answer. Correct answer. A. Explanation. Rapid cycling or short cycling stresses equipment and reduces lifespan. Introducing a minimum off-time delay ensures the boiler remains off long enough before restarting, reducing wear and energy waste. Increasing firing rate. B. Can cause overheating and is inefficient at low loads. Disabling outdoor reset. C. Removes load adaptive control, worsening cycling. Adjusting sensor calibration. D. Doesn't directly affect cycling frequency. Proper timing control prevents unnecessary boiler starts.